Curves in industrial design. Properties of B-spline curves. We've seen that a B-spline curve of degree n is a continuous union of Bezier curves of degree n. The union is defined in such a way that the resulting curve can be Cn-1, that is, having n-1 continuous derivatives. The B-spline curve is specified in terms of a set of vertices called the B-spline control polygon. The notation that we will use for these vertices is the 0 up to the m. Each vertex dk is called a control vertex. The B-spline control polygon is different from the control polygon of the curve's Bezier pieces. If the B-spline curve of degree n is a union of S Bezier pieces, the number of control vertices of the B-spline curve is S plus n. Since B-spline curves are composed of Bezier curves, they enjoy the same good design properties as Bezier curves. We will see some of these. Role of the control polygon. As in the Bezier curves, the B-spline curve starts at the first vertex of its control polygon and ends at the last vertex of the control polygon. It is also tangent and the first vector to the first edge of the control polygon and at the last vertex to the last edge of its control polygon. The curve is well localized by its control polygon, and in fact it is contained in the convex hull of its control polygon. Moreover, if the B-spline curve is of degree n, it is contained in the union of the convex hulls of every n+1 consecutive vertices. On the screen we see a cubic B-spline curve, which is contained in the union of its two convex hulls of 4 consecutive vertices. This is the first convex hull and this is the second convex hull. The control vertices or the control polygon also give us an idea of the shape of the curve. In fact, the shape of the B-spline curve is roughly the same as the shape of its control polygon. Here we have a control polygon of a cubic B-spline. Here we have the cubic B-spline. They enjoy also a property called variation diminishing property, which basically says that the B-spline curve twists less than its control polygon. Concretely, for a planar curve, that means a curve in the plane, this curve intersects a given straight line no more often than its control polygon intersects the line. When the curve is in the space, this curve intersects a given plane no more often than its control polygon intersects the plane. On the screen we see a cubic B-spline curve, and we'll see what variation diminishing property means. We have here a red line. The black points are the points of the intersection of the control polygon with the red line, and the yellow points are the points of intersection of the red line with the curve. We can see for this line that there are as many black points as yellow points. But if we move the line a little bit, we can see that for this line there are more black points than yellow points. That means the curve twists less than its control polygon. These curves also enjoy local control, meaning that moving a vertex of the control polygon affects only a part of the curve close to the vertex moved, but not to the whole curve. They are also invariant under translations, rotations, and reflections. The B-spline curve can be translated, rotated, or reflected by translating, rotating, or reflecting the vertices of its control polygon. On the screen, we can see a B-spline curve that can be rotated around this center of rotation. We are going to rotate the curve pi over 4. So, by doing this, we rotate the curve. And we can see that the rotation is only done on the control vertices. In the same way, we can translate the curve. And we can also see that this translation is done only on the control vertices. Finally, we can reflect the curve with respect to this line. and again, reflection is only done on the control vertices. When compared with Bezier curves, for the same number of vertices, the B-spline control polygon gives a better localization of the B-spline curve than the Bezier control polygon of a Bezier curve. B-spline curves are easier to control and adjust locally. B-spline curves are not polynomial curves, as are Bezier, but only piecewise polynomial. Bezier curves are a special class of B-spline curves. They are just those B-spline curves with just a single Bezier piece.